Thank you very much for the warm welcome. I'm acutely aware that I am the only thing now standing between you and the networking drinks, so I'll try and make this as brief as possible. Today I want to talk about how Sitecore is creating a security center of excellence using Elastic as our major partner, as well as the automation tools in our background, to be able to give our customers a better experience and a better service going forwards. So a little bit about me. I spent 27 years doing this. It feels like forever. And most of that has been with the British military, large-scale military systems in Afghanistan, for Defence Medical Headquarters. And most recently, previous to Sitecore, I was with Atos as their head of security architecture. And in January 21, I was asked by Sitecore to write a 3-year roadmap for their security. We started with a blank sheet of paper and a budget, and Tim very kindly said to me, have at it. And this is where we are today. And today I want to talk to you a little bit about the traditional constraints of security, what held us back in the past, and how we can change that, and why centralizing data is pivotal going forward to be able to have a better security service and to be able to automate this, and why automation is important. So let's talk about Sitecore. Who is Sitecore? Now, in 2001, it was relatively difficult to publish something to the web without having a programmer. And so 5 friends in Copenhagen got together and they created one of the first content management systems. And that's where Sitecore began. Today, Sitecore operates in 27 countries. We have approximately 2,200 staff, and we service 5,700 customers worldwide. And some of those customers are household names. We have the top 400 household names. So you'll see on the slide the likes of L'Oreal and Microsoft, but there's also bigger names like Louis Vuitton, Moët Hennessy, Porsche, and Procter & Gamble worldwide. And we provide a composable digital infrastructure for our clients to provide the best digital experience to their end users. So anything from web to email to communications and marketing strategies. What we do within Sitecore is provide security services for our products. And we have currently 6 SaaS products for the composable stack. And out of that, we do monitoring, we do governance, engineering, architecture, and we do QA and testing through our teams. So why do we need an intelligence-driven SOC? Well, that's very easy. We have a very changing landscape where everything is shifting from decentralized data to centralized data, massive amounts of data. And we also have an ever-evolving threat landscape. It's changing on a daily basis. And the pinnacle of this is being able to find really good, skilled security people is getting thin on the ground. We ourselves have found it very difficult to find skilled people. Which is why we came up with the theory that, hey, we should automate this. Let machines do the work. The traditional model doesn't lend itself very well to that. And that's primarily because people work in silos. So our security engineer performs a task, an engineering task, and they open a ticket, and they perform the task, and they close the ticket, end of story. And the same happens for security assurance as well, QA and test. They do a pen test, they do a QA, they do a code scan, and that finishes, and their report is produced, end of the task. And so they don't work together. And sometimes this information is missed. So what we wanted to do is turn that around and say, we should centralize this. So instead of having multiple streams and multiple areas of truth, we have one single source of the truth, which is why we came up with the idea of putting Elastic at the heart of this, so that we ingest all data into a central source and then automate from that central source. So you'll see from the slide, we have cyber problems coming in. So this is your normal alerting mechanisms. But as well as that, we also have threat intelligence. We have CVE libraries. CMDB data. Am I compliant against my CMDB and my assets? We have governance, risk, and compliance. Am I compliant to a standard? Am I even legal? And all of this data needs to be centralized so that we can leverage this in the security world. So now we have a situation where all our data is in one pot. And so our security engineers and our operations and assurance teams can all work together out of that central source. So instead of saying, I've done a QA test, where's the results? We can see them. We can see them instantly. We can act on them instantly. So if there's any deviations, we can deal with them instantly. And this also helps in developing our products as well, because as soon as we know that there is a deficiency, we can pass this on to the development team. So we'll create a ticket and say, hey, we need to fix this problem. And most of this is down to 3 particular areas. And Sitecore is a relatively small company, and so we don't have millions of pounds floating around. Millions of euros, I should say. Sorry. We didn't have enough available people. So in order to have a traditional call center approach for security, looking at incidents and events coming in, people staring at screens, for 5,700 customers, you'd have to have a team of 50 people. Level 1, 2, and 3 analysts. And we just don't have that available. We can't find them, let alone pay for them. So instead of doing that, we upskilled our specialists, instead of just looking at screens, to become security specialists, so that they write playbooks and use cases to automate process. So they look at threats coming in. They're very proactive rather than reactive. And this in turn enabled us to reduce our headcount. It also reduced our time taken to ingest data. Now with Elastic, it halved our time to ingest data logs. And the increased speed of log ingestion meant that we could automate quicker as well. We can write playbooks quickly. And the truth of playbooks is they're as simple as complex as you want them to be. But what we found was it is as simple as writing a yes-no decision on a piece of paper. However, it's not that simple, as we've discussed before, because you can now have multiple decision routes out of a yes answer. But our center of excellence that we have created now allows us to orchestrate multiple streams at once, wherein before we were using people to do this. The ultimate goal of this is saving money, but we're not just taking away jobs. We're not just taking away money. What we're doing is spending it more wisely so that our customer gets the benefit of this. We're increasing our security service. We're increasing it by offering more coverage. We're increasing it by offering them reports, information on their systems. How are they running? How secure am I? So our SOC architecture is built around Elastic, using Logstash and FileBeats and PacketBeats to ingest the information. But we also have a deep insights layer as well, where we take our scans and our vulnerability management data and also our Azure log data and ingest that too. And ultimately, we also have our raw logs from our applications, our audit logs. And this is all fed through Elastic when it's normalized data in the Elastic Common Schema. And here's the important part here. If you put rubbish in, you get rubbish out. So what we needed to do was make sure the data was relevant, it was clean, and it was easy to ingest into an automation tool. And that's exactly what we got with Elastic, is the ability to normalize the data. So our orchestration tool then spits out a workflow that we designed from a blank sheet of paper, and we designed 64 now custom playbooks that automate the response. So an incident comes in, it comes into our Elastic SIEM, and it alerts. It then sends the alert to our orchestrator that creates the ticket, whilst in parallel, for example, if it wants to block an IP address, whilst in parallel, blocking the IP address in Cloudflare, bringing the response back to the ticket, closing the ticket and reporting on it. Now, just to give you a little bit of statistics around that, I can't show it today, I've got 20 minutes. It took 8 minutes to do that particular action. Now, show me a human that can respond to an incident in a SIEM, log into a system, block an IP address, close a ticket and report on it within 8 minutes. And now, unless you've got hundreds of people waiting around doing nothing, that's never going to happen. Whilst we were looking at the solutions around for security, we also came up with some major constraints with traditional SIEM solutions. So the likes of IBM's QRadar and Splunk and Rapid7, all of the normal ones, had major constraints. So what are they? Well, the first one is it didn't have very fast search capabilities. So an incident came in, and it was slow to respond. It was very, very complex to bring logs into the system. Normally, it was a one-on-one basis, and you would have to have assistance from the organizations themselves to be able to bring your logs on board. In addition to that, it was really tedious to monitor when we were getting to thresholds. So it wouldn't alert you. It wouldn't tell you when you were reaching a log threshold. Hey, your space is up. Now, with Elastic, we have the capability to actually send us alerts, and we use various methods for that. We can send an email, but we can also send a Slack message to our security team saying, hey, your log's getting full up. And the last one was creating complex queries, so use cases to detect difficult anomalies. The out-of-the-box stuff was great. And if you're a Microsoft house, brilliant. If you use anything else, custom use cases are incredibly difficult to build. I know this, I tried to do it with Atos. So let's go into a little bit more depth about this. According to recent surveys, and this is Gartner and Forrester reports and everything else, analysts lose up to 20% of their day just creating a query to get the data out of a SIEM solution. And this is mostly attributed to difficult storage. Now, with Elastic, we don't have that issue. The index lifecycle management means that we can employ various architecture principles here. So we use a hot warm for 7 days to keep our logs live. So for 7 days, we keep them completely live, and it's nanoseconds to return the data. After that, we move it to the warm architecture for 90 days to reduce our costs. But it's all still searchable straight away. But here's the kicker. Here's the reason we chose Elastic. Frozen architecture. So we can search from an Azure blob frozen logs. Now, as far as I'm aware, there's no other SIEM that can do this at the moment as quick as Elastic can do it. And I'll give you a little stat. When we were doing the POC for this, we put 16 terabits of data through this, and it returned the log result in 0.6 of a second. Boom. There you go. Now, the saving in time alone is worth any company. Just that saving. In addition to that, the limited or complex log parsings that we have in various existing SIEM solutions really held us back. So we were spending months and months looking at this. And this is from my previous guys, not with Sitecore. So I was lucky enough to have the ability to start afresh. But once you have a SIEM solution, to be able to ingest things is so difficult. You have to get to the log source. Most of the time it's raw log, so you then have to normalize it. You have to build an API connector for it, and each one is different, so you have to start again. And most SIEM vendors will say, oh, we'll do that for you, and it will cost you 50,000 euros. So the ability to use Elastic to create our own ingest pipelines was just fantastic. And we managed to ingest 17 log sources in 3 months, which is rapid. And also when it comes to non-security related products, we can use the ingest pipeline to do those as well. So observability, we can do that for capacity management. We can also do it for threat intel as well. And it's so easy to use the interface that it's just a few clicks away and we're done. The tedious approach to monitoring log thresholds. Why do we need to monitor log thresholds? Well, we're currently ingesting 200 gig a day, which doesn't sound a lot, but it certainly adds up, and it fills up really quickly. And with a lot of the other SIEM solutions, they wouldn't tell you when you hit a threshold. So the biggest problem we had was, forgive me, I've made some notes on this as well. We could create a condition state within Elastic that said, if my storage gets to 90%, just tell me. If my storage rate gets to 100%, don't only tell me, tell Tim, and tell our other team to expand it as well. There is another side to this automation that says you can actually up your capacity limit as well automatically. But the problem with this is, if you don't identify this problem and you have no action, you're then at risk of attack because none of your logs are going into the system. They've stopped, they've ceased. So you're none the wiser. So we use watcher functionality for that. And as I've said, we create the condition or the rule that allows us to notify when it's triggered. The complex queries, I've talked about this already, but we wanted the ability to create a use case, a complex use case, quickly, easily, without programming skill, without having to be a genius, and to be able to put a level of complexity in that said, don't only collect one log, collect multiple at the same time. And if there wasn't a beat for it, put it into an Azure blob and pick the raw log up from there and then normalize it. So we had a solution for all logs. And this meant that we had absolute speed in bringing our logs into Elastic SIEM. Now, why is this important from an automation standpoint? We leverage every different rule type at the moment within Elastic. And the ability to use regex for that, regular expression, is absolutely paramount, because otherwise you miss certain amounts of information. So if you pick up a log, but it's not normalized, it's not correctly typed. So you could end up with, for example, you're looking for details with K and Y in them, but it only picks up the letters K and Y. That's traditional SIEM solutions. So now we've got the ability with Elastic to say, don't only tell me that. Tell me K and Y, K with Y, and even kimchi as a word. So it picks up everything, so it doesn't miss anything. And this one functionality has helped us create really complex use cases so that we can add multiple strings to it. So don't just tell me if it adds K and Y, but tell me if it has a star in it. Tell me if it has special characters in it. And then we can input from there. And as far as the automation side goes, through our use of Elastic and the orchestration side, we've managed to set up a fully functioning SOC, a 24/7 appearance SOC, in just a year and a half. Well, it says 1.25 years, so it was we had a POC for 3 months, so I'm kind of counting that as well. We're not 24/7, we're 8x5. So how do we achieve this? Automation. So by automating in the background, it still carries on when we've gone home. Yeah, but what if a major alert comes in? We have an out-of-hours team, and our automation engine sends that response to our out-of-hours team, creates the ticket for them, and says, go forth and do the work. Unless it can do it automatically, which it does, closes the ticket, reports back to us. We managed to onboard 55 custom use cases in just 7 months. That's the typical lead time for a normal vendor to assign people to do the task, create the statement of work, send you the bill, and then start the work. We don't carry over any instance every month. We close 100% of instance every month. We don't carry anything over. We're only able to do that thanks to automation. And it says that 96% there. but I can update you on that. We achieved an automation rate of 97.4% of all incidents dealt with automatically, with just a 9% error rate. That is a 9% false positive rate. As well as that, we responded to our incidents and fixed them. This isn't a response time, this is a fix time of 13 minutes. That's our average fix time. And we handled 3,600 events a week with just 2 security specialists, just 2. 27 countries, 5,200 customers, 2 analysts. And that's why automation is important and the power of Elastic. So you'll see on the incident trend as well, we've seen a complete drop in our incident trend. October's quite bad because we onboarded 4 new log sources, which is why it went back up. But as we process and as we refine our log sources and as we refine our use cases, the incidents drop and drop and drop, and the automation rate goes back up as well. So this is the power of using Elastic for its data capabilities and the automation process combined to create a center of excellence. So what's next? Well, like everybody else that's talked today, obviously we want to make a move to Elastic Cloud. We have an on-premise solution at the moment, and we want to make use of Elastic Cloud, and we're looking at that at the moment. We are moving our entire product stack to Kubernetes and containerization. And so the use of XDR for scanning our containers, apologies, Elastic XDR, to enable us to scan the container registries and the contents of those containers on both Windows and Linux is paramount. And we also want to investigate using Fleet for pipeline ingest as well. So instead of having to put beats everywhere and Logstash, we'll just use Fleet to pick up all of the ingest. So with that, I just want to say a couple of thank yous. The first one goes out to Tim van Gehuchten. Thank you very much for allowing me the budget and the freedom to create the Center of Excellence. And the biggest thank you goes out to my team. And those are Ashok Alumalai, Raul van der Vassi, Shubham Tyagi, and Arnold Stoes, who without those people, I couldn't have done what I've done in a year and a half and automate to the level we have. So the importance there is also the winning team. Thank you very much.